Hello, so today I'm going to give you another update on my project here. Today I'm working on the keyboard. If you see my other videos, you know I've already got the screen working and I've got a drive. And the next step is the keyboard. So if you see my other videos, you know that I put in a pin header here for the drive and the keyboard, port 60 for the keyboard. And the intent is to use one of these modules here to use a USB keyboard. The problem I'm having is I'm not too familiar with USB programming. This module is set up, it's great for the drive because you just set it commands and it'll read and write sectors to the drive, but you plug a keyboard in and you have to use what they call like an external firmware mode. So you have to write all the code for to communicate with the keyboard, which I haven't been able to sort out, and there's not a lot of documentation online for these for the keyboard. I've seen a few examples where somebody used a mouse and a printer, but I haven't been able to like reverse engineer their code to figure out what to do yet. But definitely if somebody knows how to use a keyboard with one of these, that would be helpful. What I've also done is I've got this for like $2 off eBay. This is like a self-contained module for the PS2 keyboard. And if you look, it's got like a parallel output, a serial output, and an I2C output, as well as like an interrupt pin at the bottom here. This actually works. It works pretty well out of the box. You don't have to have any special initialization firmware. The thing is this parallel port here though it's not something you can connect directly to your data bus. They're like always active. So if you push a key, it puts the scan code on the pins and triggers the interrupt pin. And I tried this out; it worked. I had to use a buffer, and the only thing I found with this was it only gives you the key down scan code. It doesn't give you when the key's up. And where that runs into a problem is like say your shift key. So you'll get the scan code, you pushed your shift key as you're holding it, but then you don't get the scan code to say you lifted the shift key. And I was thinking maybe just doing like all uppercase, just ignoring the shift and caps lock key. So that basically, it doesn't meet the full requirement though, it's only a halfway there. But it would work as an input for this project. The other thing is if you held a key, it would, it only just acknowledges it once. It doesn't acknowledge that you're holding the key. Now, maybe through the serial side it would, but I only use the parallel side. So anyway, I'll show you this. What I actually ended up doing is I've used this keyboard controller. It's not the 42. This is a later produced chip, and it's actually more design. It's like designed specifically to handle the keyboard. Supposed to run faster than the original, the 8042. As far as I know, I mean, it comes in different pin configurations, but this is the only one I could find available. And they're a little bit more cost. I mean, they're like $5 a chip. But I made an adapter so I could prototype with it. And then what I'm going to do for now is I'm going to take this pin header here. I'm going to put a board together with the pin header and make a self-contained unit that I can just plug right into my socket there. I thought about making a new motherboard and putting it on the motherboard directly, but I kind of like to have this where eventually we could go onto the USB keyboard. Also, if I do, or when I do get this put together, it'll be kind of like a self-contained module that you could use with other projects like a Z80 or the other type 8-bit computers of that time. So you can see it's got its own crystal. You could take the clock output off the processor on the board, but where it's its own module, I'm using my own crystal. And then over here we've got some buffers, and this is actually wired right out of the manual, except for I did not include the capacitors. I put them on and it didn't work. So I left them off for now, and So other than that, the capacitors is missing, and then on the crystal, I didn't put the capacitors as well, or the resistors that it's looking at the manual. For some reason, I'm either using the wrong value or they just don't work. So let's boot this up and we'll show you at work. Now, I haven't developed the BIOS enough yet. The only thing that it's going to do is it's going to show the scan codes. I haven't gone in there and put in the character codes. So I kind of did a self-test there. That 40AA was kind of a self-test from the keyboard. As far as I read, you want to see a 00AA, but 40AA does still work. Sometimes I get the 4, sometimes I don't. So I just push the A, and you can see I got the 1C and the 9C. The 9C is the key up code. So this works. It just needs to be, I just need to write the handler now. The nice part about this is if I hold a key, it'll sit and repeat. And then when I stop and let up, you can see I guess they call it a break code right there. Also the caps lock works. The shift, so I can hold shift. I'm holding shift now, so that's that 1, 2. And now I'm still holding shift, and you can see the A is 1C. I'm going to let up on shift, and you see that 9-2 is the break code on the shift. And so as you can see, it'll fully handle the keyboard as designed. So here shortly I'll put together like I said, I'll get a board made. Then I can just use the ribbon cable to connect this to the project. And then eventually I would like to get the USB working. So thanks for checking out the update.